This video is filmed and edited in 360 degrees. Click and drag the screen to take a look around. Go on then, click the screen and give it a wiggle.
Welcome to Derby Station. Take a look around you. Thousands of people travel through this station every day. But how does sound travel? Imagine you're sat on a bench waiting for a train, talking to a friend. To learn how you might hear each other, find the bench and center your screen on the red icon.
Please keep your personal belongings with you at all times. If you do spot anything suspicious, please speak to a member of our station team or British Transport Police. You can also text British Transport Police on 61016.
Part 1. How sound travels. So you want to talk to your friend. Sound travels through the air as a wave made up of compressions and rarefactions. A compression is where the air is pushed together. A rarefaction is where the air is pushed apart. This happens many times as the sound travels from you to your friend. Where the air is pushed together, this is a compression. Where the air is pushed apart, this is a rarefaction. You might have noticed that sometimes in places like train stations, it's not quite this easy to hear others. This is because nearby objects cause sound to travel differently. One example of how objects affect our conversations is with reflections. To hear more about reflections, find and center your screen on the red icon. Part 2. Reflections. In Part 1, sound travelled directly from one person to the other. However, in reality, sound would have travelled in many directions and may meet other objects on its way. If the sound meets something hard, like a wall, it can bounce back off the wall and reach the person at a different time. This is called a reflection. If you've ever heard your own voice come back to you, you have heard a special kind of reflection called an echo.
Testing. Please mind the gap between the train and the platform edge.
Did you hear that announcement? Find and center your screen on the red icon to see one tool an acoustician might use to help design a similar announcement system. Part 3. Ray tracing. Believe it or not, the locations of where to put speakers can sometimes be fairly complicated. Imagine the sound travels in a straight line. This is called a ray. We can use maths and physics to trace the direction a ray will travel. Using a computer, we can simulate thousands of rays at once. This technique is called ray tracing. Every imaginable surface has a specific coefficient for its ability to absorb or reflect sound. The more reflective a surface, the less potential energy is absorbed from the ray. This directly affects the ability and can be quantified using speech transmission. Don't worry if you didn't catch all of that. As the number of reflections increases, sound becomes much harder to understand. In this video, we've learnt how sound travels as a wave through compressions and rarefactions. We also learnt that objects can cause sound to reflect and bounce off them in many directions and can alter the sound we hear. We then looked at ray tracing, which is a simulation tool used by acousticians and can help them work out where to place speakers based on the reflections created by the space. Next time you're on a journey, listen carefully to the sounds around you and think about the complicated journeys they may have made to get to you.